Yeah, welcome. So we're looking at this new topic, and that's eigenvalues and eigenvectors. Okay, and we have this question for 2 by 2 matrix. Okay, so let's go to the what is eigenvalue and eigenvector. How do we solve them? Okay, how do we solve them? To get the eigenvalue, we have this equation: the determinant of a minus ri equal to what? Equal to 0. Which you can also write this equation in the same form as what? Depth of what? A minus x. Okay? So the two equations are the same thing. So these are the equations to use to get the what? To get the eigenvalue. Okay? So the question now is that how do we calculate eigenvalues? How? Okay? One, we use this get this expression. That's one. Calculate that. Then two, calculate the determinants of this expression will be equal to 0. So once you get the use the determinant of this expression equal to 0, from there you can calculate what? You can calculate your R. Your R is what? Is a eigenvalue. That's that on that. Get this expression. This is the formula we use. Then the determinant of this expression must be equal to 0. So from there, you can get your what? You can get your R. I'm using my R. R in this case denotes eigenvalue. Okay? Some textbooks use a lambda. So I'm going to stick to what? I'm going to stick to R what? R as what? Eigenvalue. Okay? So for 2 by 2, solution to this question, this is what we're going to do. Our A is a given problem, which is what? Matrix 2, 7, minus 1, minus 6. Then minus R, that's the eigenvalue, times what? Identity matrix. And then this is 2 by 2. Your identity matrix also must also be of the same form, which will be what? 1, 0, 0, 1. Okay? And that will give you 2, 7, minus 1, minus 6. Then R times this matrix, that will be equal to what? That will be R 0, 0. Okay? And then you now begin to subtract this matrix and this matrix, which means this imply what? This imply 2 minus this, that's 2 minus R, and then 7 minus 0, that's 0, and then minus 1 minus 0, that's minus 1, then minus 6 minus R, minus 6 minus R. Then the determinant, don't forget the formula. Determinant is equal to what? I say depth. Depth of this expression. Okay? Determinant is this symbol. Okay, equal to what? Equal to 0. And don't forget, this expression I write here, you can write it as what? As determinant of A minus this. So this expression and this one are the same thing. So in a nutshell, instead of wasting the time and do this subtraction, it may not be needed. Okay? So you can go straight to the points. By the matrix you have here, you can go straight to the points and just put your line. Then your main diagonal, this is your diagonal now. This is your diagonal. That diagonal minus R, 7, minus 1, minus 6 is here, minus 6, minus what? Minus R. Just the diagonal, you're going to what? You're going to subtract the R. This one minus R, this one minus R. Instead of doing all this. Okay? Just write our formula. Give us the formula. That's step 1. A minus this. Put your determinant there. Equal to 0. And then next thing is to give us this expression. Okay? So that's that on that question. So my subsequent questions, I'll just go straight and what? then use the main diagonal, and then main diagonal minus what? Minus r, main diagonal minus r. So, okay, so this is what we have now. Let's do the expansion. This determinant, this one times this one, that'll be 2 minus r into times minus 6 minus r, then minus into bracket minus 1 times 7, that's what? That's minus 7, go to 0. So then I have 2. I can start expanding. This one times this one, that's minus 12. 2 times this, that's minus 2r. This one times this one, that's what? That's a plus 6r. This one times this one, that's plus r squared. Then minus minus, that's plus 7, equal to 0. You can begin to arrange. This is r squared minus 6 minus 2, that's plus 4r. And then minus 12 plus 7, equal to 0. Then the next thing to do now is to to factorize this. Factorize this. R squared, 1 here, 1 here. Factors of 5. They can give you either by addition or subtraction. They can give you 4r. That's 5 and 1. That's 5 and 1, and that will be plus 5 minus 1. Okay, so that's that. So in that case now, we now have r plus 5 equal to 0, and that's equal to what? R is equal to what? Minus 5. Or r minus 1 equal to 0. So r is what? R is 1. So the eigenvalues are 1 and what? And minus 5. Okay, so we'll finish that. Then the next thing to do now is to get the eigenvector. To solve for eigenvector, we use the component of this eigenvector. And the component of this one is the eigenvector. So it's very simple. What we're going to do in this case is very simple. Now don't forget we have two values for eigenvalue. So for r equal to minus 5, let's solve that. Choose the leading diagonal minus 5, 7 minus 1. Here we have minus 6. So minus 6 minus 5. Okay, there's no space there. So you have the idea. So that will this now become, this will be the matrix. That will be 7 here. That will be 7 minus 1. This will be what? Minus 6 plus what? Plus 5. That's minus 1. That's a matrix. Then the component of this now is u1, u2, and that's what we are looking for. That's the eigenvector, and they equal to what? Equal to, don't forget, equal to 0. So that component of 0 also, it will be 0, 0. A column matrix. I just try to use this one to explain. Just use this one to explain. Just this one to explain. Okay. Your R value, go back to your matrix. Replace when R is minus 5, put it there. Okay. Then I'm using this formula. Then times the component of that vector. Okay, equal to what? Equal to 0. That's what we have now. So augmented matrix will be 7 minus 1 dash 0, 0. That's the augmented matrix. Then the next thing to do is a row operation. Do your row operation. And what we are trying to do here is, you can say row 2 is equal to row 2 plus. We want to make this to be 0, if possible. So this one also 0, 0, 0. Okay. So if this play can be what? If this 7 can be 1, so that 1 over 7 row what? Row 1. row 1. So we now have row 1 is the reference point 770. So minus 1. By the time you divide this one, by the time you divide row 1 by 7, you have 1 there. So minus 1 plus 1, that's 0. Here also, that's 0 also, 0 also. So that's what we have. Okay. So thus, we now have, don't forget this 1 is row 1, the first column, the second column also, all the elements there, therefore row 2. So, and if we want to do that to form the equation, it's going to be 7 times u1, that's 7u1 plus 7 times u2, 7 u2 equal to 0. Okay, so 7 we cancel out, so we have u1 equal to what? Minus what? Minus u2. Okay, then consider u2 as what? As x. Okay, u2 as x. Consider u2 as x. So that means u1 is equal to what? u1 is equal to what? Minus what? Minus what? Minus x. Then the eigenvector is this sign. Now become the u1 is what? The u1 is what? Don't forget this one, this vector. This vector, the component is what? u1, u2. Okay? So for u1, we got what? Minus x. For u2, we got what? We got x. Okay? So you can do something. You can factorize the x outside, and that will be equal to what? Minus 1, 1. So we'll take this one to the 1. Take this one to the 1. So the eigenvector is what? Minus 1, 1. Okay? Then for r equal to minus 5, the eigenvector is what? Is minus 1, 1. Okay, we've considered this one to be 1. So then for r equal to minus 5, the eigenvector is what? Is this. So let's get the eigenvector for the second eigenvalue. I think when r is 1, let's get the corresponding value for the eigenvector. So let's now get, let us calculate r equal to 1. So let's calculate that. Let's calculate the eigenvector corresponding to r equal to 1. So we're still going to use the same formula. We're using this formula, a minus this, then this equal to 0. Okay, so we'll go back here, go back to that equation when I said 2, the main diagonal minus what? Minus r, minus r. Just go back there. Once you can go back there, that's solve the problem. And that will be what? That will be, I think this is 2 minus what? Minus 1. That will be 1, 7. This is minus 1. And then minus 6, minus 1. That's minus 7. u1, u2 equal to what? I can put the component of the 0 also. 0, 0. Okay, so augmented matrix, that will be what? That will be 1, 7, minus 1, minus 7, put your slash here. That will be 0, 0. Okay, so that's what we have. Then we can do the row operation straight away without wasting time. Let's make this one the baseline, row 1. So that will be row 2 is equal to, since this is, we have the same value, but this is negative, this is positive. Then we do addition, that will be row 2 plus what? Plus row 1. And we are very lucky the values are the same. Okay? So we have now, in this case, 1 is the reference point, row 1 is the reference point. This plus this, that's 0. This plus this, that's 0. Equal to 0. This one plus this one also, that's also 0. So that's what we have now. So we now have, therefore, we have, don't forget the first column is for U1, U2. So that will be 1 times this, that's a U1, plus what? This times this, 7 U2 equal to 0. Then U1 is equal to what? Minus 7 U2. So consider what? Consider U2, let's call it this. Okay? So that means U1 is what? U1 is minus 7x. So therefore, the eigenvector is equal to, my U1 is a minus 7x. My U2 is what? X. Okay, you can factorize this one, take it outside, and that's what? Minus 7, 1. So therefore, minus 7, 1 here is the what? Is the eigenvector corresponding, is the eigenvector corresponding to r equal to 1. Okay, so that's that on these aspects, calculations of eigenvalue, eigenvector for 2 by 2 matrix. Okay, the next video will be, the next clips will be calculations of eigenvalues, eigenvector for 3 by 3. Okay, so please, if you're new on this channel, please subscribe right now. Do it now. Click on notification bell, click on like button, and begin to make your comments, type your comments.